Get back to here. And this is an enterprise server. This whole thing can be hacked by a single image. Okay, in other words, if you read the text here, they describe it a little bit better. There are remotely and easily exploitable vulnerabilities in the BlackBerry Enterprise server that will allow an attacker to gain access to the server by simply sending a malicious image file to a user's BlackBerry device. That is not good. Definitely not good. Because you're not hacking the BlackBerry device itself, you're hacking the server, where all the email messages and contact information are stored. And you can do it by just sending a malicious image to one of the BlackBerry devices. In other words, you're just sending a picture. Okay, this is a picture of the Sierras. Okay, it's snowing up there, and then you can a hacker can maliciously modify the picture so that it still looks like a regular picture, but when it is sent to the server will get hacked. Yep.
Is there protection for the phone? Like I have Lookout on mine, which is supposed to be a protection like that. But recently, I haven't been able to get into my bank account on the first try. It takes like 3 times to go through my phone to get onto it. And then also, my phone will just randomly shut down.
And you have an Android phone, or you might want to have it checked. I don't know who would be the best people to check it, but you probably want to have it checked. It can be an issue with stability, which is not getting hacked. It's just the device itself is not stable, but it can also be getting infected. So you definitely want to get it checked. Yep.
You don't know who does that?
I do not, unfortunately.
You can probably go to your carrier and talk to them about it.
Yeah, they'll just ask you to buy a new one.
Yeah, exactly.
It's time to upgrade. Another 2-year contract. So anyway, you can read about this one, but it's things can be hacked pretty easily.
So since your phone is basically like I can hook up to my Gmail account and have everything just transfer onto my phone automatically, is the Gmail account also would the Gmail account be affected by all that stuff?
Well, your Gmail account cannot be infected per se.
Because you're talking about contacts and pictures and all that stuff is stored in the Gmail account.
Right. However, someone who gained access to your cell phone will be able to get the password to gain access to your Gmail account. So that can be bad because they can use your Gmail account to send out malicious email to other people on your contact list. So potentially that can happen.
So change your passwords on.
Yeah, but don't change your password on your cell phone because your cell phone is already suspected to be hacked. So you want to do that on a computer where you know it is still secure. Yeah. But before you update the password on your phone, you have to make sure your phone is clean before you do that.
That's what I'm saying. Like if I buy a new phone, will all that the same problem transfer onto that new phone?
That's a good question. That's a very good question. Because it depends on whether the source of the problem is coming from one of the apps that you have already installed. With Android devices, they can sync the apps to. So when you buy a new device, the new device can install the same apps that you already had installed on your older device.
Right.
So if the source of the problem is one of the apps, then when you buy a new phone, the same apps will get downloaded and installed on your new phone, and the same problem would happen. So you kind of have to, maybe make sure that it does not sync the apps before, so that you can, just hand pick, the apps that for sure are clean before you install those on your new phone.
See, that's the thing. I never hear of anybody having any problems with like the iPhones and stuff. All the other ones.
Well, the iPhone has problems too. I'm pretty sure it is susceptible to this kind of problems as well. Yep. Go ahead.
Well, the first thing is Lookout. I did some research on Android mobile security, and Lookout, while it does slow down your processes, it's probably one of the better security softwares out there. There just isn't a lot, period. But also, all the malicious things that happen on your phone are basically due to apps and the security permissions that they have. And so whatever virus or whatever, you don't really get it like that. You get it through a malicious app. So like he said, go and handpick the apps that you have rather than
have them transferred on to the next one.
Yeah, and solving the problem might be as easy as uninstalling the malicious app.
I really don't have any. I have bank things and then nothing like games or none of that stuff.
Well,
on there.
it's not necessarily games that are viruses, they can be utilities or anything else. It's just check the reviews before you install something.
Yep. Good advice. All right, so we are now moving on to topic 2 finally. So we are done with topic 1. We are moving on to topic 2. This is the cover story of topic 2. I'm beginning each topic with a cover story, just basically to establish a context of the content of that particular topic. So in this case, we are talking about, in the previous topic, we started off with material that we are most familiar with. We talked about applications, and we talked about the operating system, because those are the things that we really care about. Okay, I want to use my computer for this purpose. I want to use my phone for this purpose. I want to play games on my computer. I want to work on Word documents on my computer. I want to be able to maintain contact with my friends on my phone, and so on. So these are the things that we really care most about, and that's why I started off with those topics. In this particular topic, which is topic 2, which is a really big, it will have more content later on. We'll look one level deeper to investigate what makes useful software possible. In other words, we know that applications are useful. Okay, we use it for to type up our English paper, history paper, and whatnot. We get entertainment out of our games. They're just useful or entertaining, and we like our software. But what makes it possible? Okay, we're not talking about the development or programming side of software. We are talking about, what about the hardware? What about the hardware that makes software possible? The rest of this, is really just going back to the analogy of software is basically the operation manual intended for someone to follow. So you can have the best operation manual, but if there are no workers to follow the manual to actually do the work, then the operation manual is useless, because it's useless by itself. Computer hardware refers to everything that we can see, touch, break, recycle, and so on and so forth. So all of that stuff is hardware. There are a lot of technical detail to hardware, and there's no way a 3-unit class can cover everything in detail and hope that anyone can absorb and learn from it. Okay, the textbook has is really this thick. The textbook that you originally purchased for this class is about this thick, and they talk a lot about hardware stuff. I'm going to condense it, and start off each topic with something that we care about, and then we will just look into some of that stuff to the point where we understand. Okay, so if I look at this in general, overview, as an overview, this is how it works. So we'll start off with things that we interact with first, and then we'll go into something that is more detailed and technical. So the cover story is really just here to establish a context for this particular topic and relate it to something that we have already talked about. This part here, it will have more links. I just don't have time yet to create more links, but this one is good. Okay, this one is pretty long already, and it talks about a lot of the important stuff that we really need to know. Okay, so we'll start off with things that we interact with. Things that we interact with would include the mouse, the keyboard, microphone, speakers, the screen, the display, and so on and so forth. So we'll start with those particular items, and then we'll see, we'll go into the box later on. So we'll take a look at what the processor is, what is memory, what is the hard drive or mass store device, and so on. We'll start off with the keyboard. Okay, I know this is all text and no picture, but you can always get the pictures somewhere else, right? Okay, so we'll start off with the keyboard. The keyboard is one of the simplest devices. If I have to pick one thing to explain, the keyboard is one of the simplest devices. So we'll go ahead and take a look at what a keyboard is. When you look at one key on a keyboard, it's nothing more than a switch. Okay, But it's not like a switch on the wall, because the switch on the wall can remember once you flip it, it stays on, and then you will have to flip it again to turn it off. A key or a switch on the keyboard is what we call a momentary switch. A momentary switch is one where if you push it, it's connecting, and if you release it, there's a spring to push the switch mechanism back up again, and it disconnects. Is that okay so far? What a momentary switch is, as opposed to a light switch that we normally use. So when we press on the key, we are making an electrical contact and completing a circuit. If we let go of the key, it disconnects that circuit, and as a result, there's no electrical contact anymore. So that basically is what the next sentence is about. Is when you press a key, it completes an electrical circuit. When you release a key, it discontinues or it breaks the electrical circuit. This means that with a 104 key keyboard, which is your typical keyboard, has 104 individual switches. Are we doing okay so far with this concept? Okay. But what about that control key on the left versus the control key on the right? Aren't they the same switch? The answer is no. Okay. The right control key and the left control key are two separate keys. And we'll talk about, how can the computer know that these are two separate keys, and how come they have the same effect when if I use either one, it seems to be doing the same thing. Internally, the keys are arranged in a grid using the concept of rows and columns. Okay. I did not have time to draw a picture, so I can either draw a picture on the whiteboard now, or I can use Inkscape to draw a picture. I think that would be best. So we'll go ahead and use Inkscape for this purpose. And in this case, the color is definitely important. So what we have here are rows and columns. So I'll just go ahead and draw a few rows and a few columns. And I'm going to change its color. So stroke paint, we'll make this red and make it thicker. Okay, go. And then we'll make copies of this. So duplicate. Duplicate, like this. So I have 3 rows here, and then I will make columns. So columns will go from here to here, and we'll change the color to green. Green like that. Use the same thickness, which is 5 pixels. There we go. Okay. I'll just make 3 rows here. Now the red lines are the rows, and then the green lines are the columns. So what happens is the keyboard controller, which is a computer inside the keyboard itself, is constantly scanning. Okay, it's constantly scanning either the rows or the columns. So in this case, I'm going to make the rows scanning, and then the columns to be driven. Okay. So I'll just present a voltage here on one of these. So I'll use text to represent that. So let's say this is the only row that has a positive voltage. Everything else has is not driven, or it is it's not driven. If a key is pressed here, okay, then this red line will sense the positive voltage. Okay, is that making any sense?
Yeah.
Okay, let me just use a circle to represent a keystroke. So keyboard, we're going to use a fill. So that's basically is representing which key is pressed. If I press this key, there's a positive voltage here, and the key being pressed is completing a electrical circuit. So as a result, the positive voltage will also be sensed on this line. The other red lines cannot sense a positive voltage because it is not connected to the green line that has a positive voltage. Is that making any sense?
No, say that again.
Okay. Let me change the picture. Okay. Well, I'll explain this one first. If the green lines, if out of all the green lines, only this green line, which is the middle one, is driven by a positive voltage, which means it has a voltage on it. The other ones do not have a voltage on it. Okay. If I don't press any key, okay, let's say I'm not pressing any key. So this key here is not being pressed. Then all of the red lines cannot sense anything because none of the red line is connected to the green line that is driven with a positive voltage.
Which means you're not pressing no keys.
Exactly. So the keyboard controller will say, nothing is happening. You know, you're not pressing any keys. Okay. Now let's say I'm pressing on a particular key. It doesn't matter which one. Okay. Let's say I'm pressing this key here. If I'm pressing this key at this point in time, none of the red lines will get a voltage either because only the green line in the middle is driven. And I'm not making any connection to any of the red lines because the green line on the key that I have just pressed is not driven. So the red lines are not getting anything either. Is that making any sense? Okay, because this is the only line that is driven, but there's no way for this line to connect to any of the red lines because none of the keys, this one, or this one, is pressed. So there's no way for me to sense any voltage on the red lines because there's no electrical contact. Now, what if the keyboard controller says, okay, I guess nothing is pressed on this column, let me try the next one. So this time it will turn on the voltage only on the third column. So at this point, the voltage, the positive voltage here, will go onto this wire, and because this is a electrical switch, it's completing the circuit. So now this red line will also sense a positive voltage like that. And that's how the keyboard controller can figure out which key is being pressed. Yep.
So if I understand you correctly, by pressing a button, you're breaking a connection with the circuit.
You are establishing a connection. You're not breaking. Yeah, when you press a key, you are making a connection.
So you can't possibly press two buttons on the simultaneously.
Yes, you can. Yes, you can. Because if I press two keys here, okay, so let me duplicate this one. If I have another connection here, then I will also sense the positive voltage on this red line. So you can press multiple keys and you can sense multiple keys at the same time. Yep.
And it's scanning beyond while you're having a keystroke, right?
Yes,
That's
the
how you
scanning
have control
scanning
of the
frequency is so fast that it will as long as you're not a robot and you're actually pressing a key as a human being, it will pick it up. The scan speed is so fast that it exceeds the mechanical speed that we can type.
Well, what I mean is just because there's voltage going down one line doesn't mean that it won't notice that you pressing another key on a different column.
Correct. If you press another key in a different column, okay, let me duplicate this over here. That key here is not sensed at this point, but it will be sensed when this voltage is moved back here. Then this one will not sense anything, and then only this line will sense something. Now, if the scanning is going onto this one here, then none of the red line can sense anything because they're not connected to the red lines at all. Yeah. So basically, this is being scanned, like this. It's alternating between the three columns at a very high speed, so that you can differentiate, which key is being pressed. But it is internally organized like a matrix, kind of like this. Either the rows are column, and then either the columns are driven, and then the rows are sensing, or the other way around. There was another hand. Yep.
Those keys you're talking about are for left and right. Apply for the left keys and the right keys.
This applies to every single key on your keyboard. It doesn't. Yeah, they're all arranged like this in a grid format. Yep.
So each keystroke has a unique voltage or unique current?
No, They're not unique at all. It's not the uniqueness of the voltage. It is whether there is a voltage or not.
So how does it differentiate the letters or the characters on the keyboard?
Internally, they're all arranged like this. Okay, if this grid, so right now I have 9 keys. Okay, so this particular configuration can handle up to 9 keys because we have 3 rows and 3 columns at this point. Okay, your keyboard has 104 or something like that, so 11 by 11 will easily take care of that. I don't know exactly internally, how many rows and how many columns it has, but basically they're all arranged like this. And then the keyboard controller, which is a computer on the keyboard itself, is doing the scanning. So it will only drive one green line at a time. And then as the green line is driven, it will go through all the red lines and see which one is sensing a voltage. And therefore, it can sense which key is pressed and which one is released.
So the control of delete is like a macro key press.
Sorry?
Pressing control of delete.
Control Alt Delete will require 3 keys to be pressed at the same time, but the keyboard controller can sense all that because unless you press the keys so quickly that it cannot sense it in one scan, then it will miss that one key press. But I think this is scanning at such a high speed that mechanically speaking, we cannot type that fast. Are there any questions? Yep.
So the keyboard controller picks up a location on the keyboard and not the voltage?
It's picking up
Like a location?
a location. It's picking up the voltage
Okay, but
because it is sensing. See, the red lines are for sensing and then the green lines are driven.
if none of the voltages are different, how does it translate?
Is it like Morse code?
How does
Okay.
it translate that?
How does it translate that? That's a good question. We'll address that next. Okay, that's a very good question. It's not like Morse code. It really is just column and row. Okay, to the keyboard controller, it's just okay, I sense a key here, and the location is 3rd row, 2nd column, and so on. So that's internally how a keyboard controller sees the keyboard. It's really just rows and columns. And those rows and columns, may or may not have anything to do with how we see the keyboard when we look at the keyboard. Okay? Because internally, the wiring of the keys does not have to follow the same geometry. It can be internally wired in a different way. But in the end, everything is translated into rows and columns. Okay? I'm sensing a key on this row and this column. I'm sensing another key at this row and this column. I'm sensing another key at this row and this column. And that's the information that is sent back to the computer. In other words, when you press the A key on the keyboard controller is really not sending a key, lowercase a is pressed. That's not what it is sending to the computer. It is really just sending in the form of column and row back to the computer. So how does the computer know that really is the A key, and in fact you're not pressing the shift key at the same time, or the caps lock is off, so it's a lowercase a and not an uppercase A? It's all software in the computer. Okay? Yep.
A reference table per se?
There is a table to map, the column and row to specific, keys on the keyboard, and that's why if you want to switch from QWERTY to what is the other keyboard format? Dvorak, D-V-O-R-A-K. Okay, Dvorak. And if you want to switch the layout of the keyboard, it's a software thing. You don't need to change the keyboard. Now, if you look at the key on the keyboard, it will look very confusing because when you press the A key, it's actually something else, right? But to the computer, it really is just sensing the columns and rows, so it doesn't really matter. It's just changing which column and which row is the A key.
So in that same way, using that same method, then that's how we can have a keyboard that has characters on it, say for like Chinese.
Well, Chinese is kind of like a special case because the Chinese keyboard really, for the most part, you can use an English keyboard to input Chinese because of the pinyin method of input.
Right.
Yeah, romanization really makes it easy because everything can map to a English alphabet letter, and then you have the intonation, which is just 1 to 4, to differentiate which intonation of that particular character. Now there are multiple characters to one pronunciation, but then it presents a list, so you can pick from the list. And it makes the most commonly most commonly used characters appear first. So that's usually like one or keystrokes away from once you specify the pinyin or the pronunciation.
My mom is German, and we have a keyboard, and it's the exact same keyboard that we changed to use the 3 or 4 extra characters that are in the
Yep.
German. Like it's the same letters and all that, except a few more.
They're mapped slightly differently.
Exactly.
Yep. I used to have a keyboard like that in my office. This is because I did not read the description on eBay carefully. Okay. I bought a keyboard. I only like keyboards that resemble the key layout on my laptop computer. So it's expensive. Okay. So normally it goes for like $80 or $90, and I found this entire batch of keyboards on eBay for like $30 each. I go like, wow, that's a good deal. I'll order 3 of these. Okay. When it arrives, and it's like, oh, it's not English. It's not an English keyboard. It's a European keyboard. So instead of $, it has the euro sign and stuff like that. And the keys are all kind of like at different places. But you know what? The layout is actually identical to an English keyboard. It's just the lettering is different on the keys themselves. Okay, if I went through the trouble to kind of label each one appropriately, as in an English keyboard, I could have done that. But because I'm a touch typer, I don't really look at the keyboard when I type. It doesn't bother me at all. It's like, oh, okay, I guess it still works like a regular keyboard because the column and the rows are still sent out exactly the same way. It doesn't change that.
It doesn't care what was printed on the little line.
Exactly. Yep. In fact, it's a security feature because if I even leave my password next to my desk to log into my computer, most people look at the keyboard go like, wow, that's a strange keyboard, but I guess I'll just follow the password and type it on the keyboard. Well, that's not going to work because the keys or the caption or the little description on the key themselves, those are all wrong. If they follow that instead of touch typing, there's no way they can put a correct password into the system. I should try that. Just mess around with someone.
It's convenient security right there.
Yeah. Once again, this is called security by obscurity again. Yep. It's not encryption. It's just obscurity.
You could use the base of that keyboard, the
Right.
European one that you have, pull all the keys off of it, and put the
Yep.
American keys on.
I thought about doing that, but it was too much trouble. And since I was touch typing anyway, so it didn't really matter to me
Keep
one
some
way or another.
uniqueness to your keyboard.
Sorry?
Unique keyboard.
Unique keyboard, right? But it broke already, so I had to buy a new one again.
What about the other 2?
Yep, I still have the other 2. They all broke at about the same time, which is kind of interesting. That tells me something inside, like a capacitor or something like that, is not specified correctly. All right, so is this okay? Does everybody kind of have a general sense of how a keyboard works? Okay. So, okay, now between this, the keyboard, and the USB connector, and the computer, what happens when I release a key? Okay, when I press a key, the keyboard controller will do all this scanning and then detect it and say, oh, you know what? A new key is now pressed. Let me send that event to the computer. Okay, so what it does is go through the USB cable, and it will send a message to the computer, and it basically says the key that is on row 5 and column 16 is now pressed. Okay, and it was not pressed before. Okay, that's the key. It remembers the configuration of the keyboard from before. It only reports changes on the keyboard. When you press a key, it reports an event. When you release a key, it reports an event. But as long as you hold the key down, it does not keep reporting that key event because nothing has changed. That key has been on for some time already. Okay, nothing has changed. So what about that auto repeat thing? When you press a key for long enough, you'll see the letters going like that. Okay, give you a little demonstration. Just have to go to the text box. If I just press the key A, you can see it's auto repeating. So isn't that a feature of the keyboard? Nope. It's the operating system doing it. The operating system keeps track of which key is pressed and how long it has been pressed.
Is that the
Okay.
same with fast typers? Because I know some people that type pretty fast. Like you type fast, but I know some people that type faster than you.
I cannot type that fast because I cannot think that fast either. Some people can talk fast, because they can also think fast, but I cannot do either. But that has nothing to do with auto repeat.
No, about what you were saying about it sensing when the keys are pressed.
Right. But the keyboard controller can keep up with the fastest typer because, mechanically
That's what I
speaking,
was-
they cannot exceed the scan rate of the keyboard controller itself. The keyboard controller can scan easily 100 times per second. I mean, no one can press a key so short where, within 100th of a second, it is pressed and depressed. So, as long as the event cannot occur within 100th of a second, then the keyboard controller can get its job done and say, okay, I got it done. Okay. Now, internal to the keyboard, there are other things, that I actually did not talk about. When you press a key, it is not registered as a single event because, a mechanical key has a physical characteristic of bouncing. So when you press a key, it's actually like that until it stabilizes. The keyboard controller, would actually do the debouncing in software, so it registers as one single key instead of a whole bunch of keystroke events within, a fraction of a second. So that's why, the keyboard controller is actually a computer doing, some really basic things, but it's nonetheless, very important. So are we still doing okay with this picture? How a keyboard controller, senses the keys and which keys pressed. Okay. So we can now go back to the notes here. And this is really the same thing that we were just talking about, but without the picture. So now I can include the picture into here. And we talked about this part already. A keyboard controller has the intelligence to scan the keys continuously for their states. In other words, it will only report something that has changed. A key is now pressed, a key is now released, and so on and so forth. In the past, keyboards connect to a special computer port called a keyboard port. Okay, that is not true anymore because most keyboards these days are USB. So you just hook it up to one of the USB ports and you're done. Are there any questions about how a keyboard works? Yep.
The keylogger, the hardware ones, they're looking at that Morse code, right?
They're looking at the scan code. Yes, they're basically logging everything through USB to the computer.
And they use their own software driver or whatever to interpret it.
Yes, it has to understand two things. It has to understand USB itself, the protocol of USB, and it also has to understand, how the scan code. Okay, because what it does is it really is passive. It's just eavesdropping on the USB, and not it's just eavesdropping, and pick out all the important things and store that in an internal device. A USB keylogger, if I had to design one, I can probably make it the same size as a USB plug itself. In other words, it's for the most part, it's invisible.
Yeah.
It would appear that your USB plug is just a little bit longer than it should. So so that means I can see people going to the library and checking behind the back of the computer, make sure there's no keylogger first. Or bring your own keyboard. Unplug the one from the library and plug in your own keyboard. Why would I do something like that? Because a keylogger can be built into a keyboard too. Is everybody getting that part? Nobody seems to be alarmed in any way.
It's not surprising at this point.
Not surprising anymore. Because a keylogger can be built into an actual keyboard. No one says that the keylogger has to be something that you plug to the computer end. It can be on the keyboard end too. Okay.
You have to take the keyboard with you if you were the hacker.
If you were a hacker, there are several ways to do it. You can have a special software driver to get that, to get the key lock from a special keyboard.
So you just log into the computer and then run whatever.
Yeah, there are ways to do it. Maybe there's a little switch on the back where if you press the switch, it will automatically mount the storage device for the keylogger into another drive. Then you have access to that drive, and then you can download everything.
I see.
there are little tricky ways you can do it, or you can also have a special hotkey combo that activates the storage device so it becomes visible on inside Windows. Then you can just drag and drop the file, and then you can press another hotkey sequence to hide that special storage device again.
Bluetooth keyboard where it's not hardwired.
Bluetooth, Bluetooth has its own problems. Okay, now Bluetooth keyboards, are not easily hacked like that, but because the connection between the USB plug to the computer, you can still have something in between to log the events. Okay, now barring that, Bluetooth itself is not a very secure protocol. As a networking protocol, Bluetooth, pretty much inherently is not very secure. So you're basically broadcasting, all your, keyboard events using a Bluetooth, keyboard. Now it is encrypted, but the encryption of a Bluetooth device is actually very weak. So it is actually less secure than a wired keyboard in many, many ways, because now a hacker can be in any position, and as long as he or she has an antenna that is strong enough or directional enough to pick up the radio wave from your Bluetooth keyboard and break the encryption, they can see everything that you type without physical access to your computer or your keyboard. So that's kind of really bad in a way. Yep.
How about from the user's perspective? How can we protect ourselves from keylogger? Is there software that we can download, or is it part of an antivirus? It's not a virus?
No. There's no defense against hardware keyloggers. The only way against a hardware keylogger is to look at the keyboard port and make sure it doesn't have an extra thing in between.
How about software keyloggers?
Software keyloggers, you can use anti-malware stuff to stop it, because they are usually considered malware. Okay. And just to be sure, we can look into Bluetooth encryption. Right away, how secure is Bluetooth encryption? This is from Tom's Hardware, so it's a fairly reputable source of information. Once again, the computer is being quite slow. All right, so let's take a look here. Okay, Bluetooth encryption by itself is considered secure. It's a key size, 8 to 128 bit, but 128 bit encryption is not secure, by today's, standard. And this is written in 2004, so I would basically say, Bluetooth encryption is not secure by today's standard.
Well, they all kind of come with like that standard 1, 2, 3, 4 passwords.
Exactly.
0.
Yep, exactly. So that means an eavesdropper can probably decrypt your keyboard events, pretty
Unless
easily.
you change it, maybe set up a longer.
Even if you
string
change
or
it,
something.
but if it's 128-bit encryption, it's still very weak by today's standard. Okay, do you guys have a question back there? No? Okay. All right. Yep.
At the top of the class, you were talking about password, random generating software.
Mhm.
Sometimes we see the movies where they try to access a secure building using a card, and they have this keypad, and you see the numbers spinning really quick as it activates that. Or is that just sci-fi? Is that just
That's not sci-fi. That actually can be done. But that technique, depends a lot on the devices. Most of the time, these, okay, there are different types of ID system, or in order to gain access to, say, a building, that's smart card thing. Okay, one, we don't swipe cards anymore. Okay, that's kind of a thing of the past. A lot of times, those security cards are wireless now. So instead of swiping it, you are actually just hanging it over a particular sensor, and then the door will open if your ID matches. Okay, but there are also different ways of matching the quote unquote matching the ID. The oldest way is simply to broadcast what the card ID is, and then the mechanism will compare your ID to a list of IDs that should have access to that door at a particular time. So if it does matches, it finds your entry, and it is during the time frame where you should have access into the building, then the door will open. But that method is susceptible to eavesdropping. If somebody can copy your ID and create their own card with your ID, then they will also gain access to the building. So later on, they change it to a challenge and response model, where using encryption, the device would actually challenge your card, okay, with a particular question. Your card has to answer the question, with a particular answer. If the question and the answer, matches up, then it will pass, and then the door will open. Okay, then someone cannot really copy your card anymore because the question that is asked from the other side will keep changing. So no one can actually, and quote unquote, can anticipate what the next question is supposed to be, and therefore no one can actually anticipate what the answer is supposed to be to that question. So that's so there's definitely a evolution of the authentication mechanism, when it comes to door entry, stuff like that. So the days where you can swipe a card or you can plug in something and you can see all the code, changing really rapidly, those days are pretty much long gone. Yep.
Yeah, like my dad, he's 24th year in the Marine Corps, and in some places where he goes, some bases, he has to put his eye to like
a retina
thing,
scan,
and it's like a beam. But it's not really like a beam; it's like a sensor.
Yeah, it's a retina scan in that case, because the blood vessel configuration on your retina is pretty unique. So they can use it, to kind of establish the ID of a person. But that mechanism has its own flaw too, because it's an optical system. So a picture of the retina, blood vessels, using a particular lens system to pretend it is actually coming from an eye would also work. Same thing with the fingerprint. You guys know how teenagers can get around fingerprints. They can use Scotch tape and baby powder, right? Yeah, so they can get around those things pretty easily too. Any other questions? No other questions? Moving on, continuing with our topic on hardware. Okay. Next one is a mouse. Okay, the mouse seems to be a pretty simple thing to figure out. Okay. Good thing this is a cordless mouse, so I can actually use it as a prop too. So, how do you think a mouse works? Well,
LED.
there's an LED light. Okay, it shines on the surface of a piece of paper or whatever surface it's on, and there's a camera. So if I have to draw that as a picture, you can actually look it up too. If you just, I can use my other mouse. Okay, you just look up optical mouse and go to Wikipedia. It has pictures and a much more detailed explanation.
But with the touch and slide screens now, is the mouse obsolete? With the touch screen and slide screen, is the mouse obsolete now?
I don't think so. I do not think so. But let me just see if it has a picture of how a mouse is supposed to work.
Mouse far more efficient than touch screen.
Okay, it doesn't have that picture, so I'm going to draw that on the whiteboard. So let's say this is a surface. Okay, this is the surface that you're resting your mouse on, and this is a magnification of the mouse. Okay, the sensor, at the bottom of your mouse consists of two components. One component is called the LED, for light emitting diode. Okay, so the LED will basically shine light, and typically at a very steep angle, kind of not like this, but on the side. And there's a camera. It's a very high speed but low resolution camera. So the camera is basically looking a very close look at the area that is illuminated by the LED. Okay, and the camera is a very high speed camera. So when you move the mouse, the image that you are capturing here will also change. But it will try to figure out how the image is changing, and therefore establish the relative motion of the mouse itself. Is that making any sense? Okay. So do you think this method will work on the mirror?
No.
Yes, go ahead.
Some of the earliest optical mouses, the mouse pad was actually the mouse pad for the earliest.
Has special dots.
It was like
Patterned, right.
Yeah.
The new mice that we have today, because the resolution of the camera is so good, and also the light source is a point source or is very directional, it is well enough that most of the time it will work on a mirror. What we consider a featureless, flat, and smooth surface still has micro features that is not visible to our human eyes. But this thing, being so close to the surface, it can actually pick up the micro features on a smooth surface like glass. And most of the time it has to do with the LED being shining on the side, and some of the newer ones do not use LEDs, they use what? Lasers. Okay? They use a laser going through a particular lens to illuminate the surface. Now the nice thing about a laser is, it is a point source, which means, any feature on the surface will really stand out with high contrast when it is illuminated by a laser, as opposed to an LED, which does a job, it's okay, but it's not as good as a laser. Okay, and that's why all the new gaming mice, they all have a laser instead of an LED to illuminate the surface, and therefore it's much more sensitive, and it will work on just about any surface. Are there any questions about how an optical mouse work? No questions. Okay, the next question is, okay, so if a mouse can only pick up relative motion, what is being sent back to the computer? When I move the mouse a little bit, okay, I'm just using this as a prop. Let's see if it works. Yeah, it works. See, the whiteboard is completely featureless to us, to our human eyes, but to the mouse, it doesn't have any problem picking it up, and it's very accurate too. This is very accurate tracking of my motion. That really is, saying something about the technology. Okay, so the question is, when I move the mouse a little bit like this, what is being sent back to the computer? The coordinate or what? Go ahead. You don't want it? Okay, go ahead.
The XY axis.
It's sending back the delta,
Direction and speed.
or direction and delta. In other words, it's really just sending back the mouse is now moved to the right by 7 counts, okay, or it's moving up by 8 counts or whatever, okay, positive or negative, because you can go in both directions. It's not sending back the absolute location, it's sending back the change of location instead. So how come the computer can keep track of this mouse? It is now at the kind of like a 1/2 low and completely to the right hand side. So how can the computer know that I'm now moving all the way to the other side? It's the computer itself keeping track of the current location of the mouse pointer, and as a result the change is just added to the current location, and that's how the whole thing works. This thing is not very smart by itself. Most of the features or most of the smartness comes from the computer itself. There was a hand a little bit earlier. Go ahead.
The way I understood it before you explained it now, I thought it would take one picture using the camera and then take multiple pictures, and that determines how fast or how slow it's going and what direction.
No, it's just continuously scanning, and it will continuously report back to the computer what is the delta or what is the difference, what is the change between the scans. So the faster it can scan, then it can respond to smaller or even faster changes. And that's why gaming mice are a little bit different, because they're more sensitive.
Instead of using a camera, would it make more sense to use an accelerometer?
It's much more precise. Now, what you're talking about is sensing the acceleration and deceleration. You can do that to a certain accuracy and precision, but this is using the optical way is actually much more precise. Okay. Any other questions about how a optical mouse works? Okay. If there are no questions about what an optical mouse works, the next one is a microphone. Now, a microphone is actually considerably more difficult compared to a mouse or a keyboard, because it is not a binary device anymore. It is now a analog device. Okay. We still have a minute and a half, so I still have a little bit of time to kind of talk about what a microphone looks like, and we'll go through the overview, and then we'll talk about the details next Tuesday. Okay. when you look at a microphone or when you look at sound wave, what is sound wave?
Vibration.
Vibration. A vibration, is what can trigger sound wave. But what exactly is sound wave itself?
It's like sonar. It's like sonar.
It's like
Sonar.
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 It's like submarine.
Kind of. Okay. Go ahead.
It's energy being pushed through the air.
Propagated through air
Yeah.
by. Go ahead.
Down to the very finest point, it's light.
It's the change of air pressure. That's basically what sound wave is. In other words, we are not moving air. When I'm talking and you guys are listening, the air from here is not moved to your location. Okay? So in other words, for the most part, except for the HVAC and all the other air circulation thing, that air that is around me is still around me. So what you're hearing is not, transmitted by the movement of air from here to your place. Because light is like that, okay? When we shine light on something, we're actually pushing photons to the other side. But with sound wave, it is the pressure wave that is moving. In other words, the air that is around me would be compressed and then decompressed, compressed, and decompressed. But that motion, that change of pressure is what is propagated from this location to your location. So what your eardrum is doing is to sense the pressure change at your location, and that is interpreted as sound. Okay? How does a microphone work? It's kind of like an electronic ear, right?
Yeah.
It senses, pressure change by a diaphragm, and when the diaphragm, when there's compression, the diaphragm will compress, and it will sense, the compression using various mechanisms. When air is decompressed, the diaphragm will expand, and so the movement of the diaphragm can be encoded. The next question, okay, we're running out of time. You need to think about this. Is the diaphragm going like this, decompressed, compressed, decompressed, or compressed, or do you think it can go anywhere in between? That's the question. We'll talk about this on next Tuesday.
Right when it was getting good. I said right when it was getting good.
All right. Well, you can read about it too. So it's all
Oh, crap.